Picture this. You're sitting at your laptop. You've just finished a small feature, a button, a bug fix, maybe a config change. You type 3 words, git push origin main. You hit enter. You lean back and grab your coffee. 2 minutes and 14 seconds later, a green checkmark appears on GitHub. Your code has been checked out, built, tested, and verified automatically on a fresh virtual machine you never touched while you were sipping that coffee. No FTP client. No SSH session where you're copy-pasting commands and hoping you didn't mistype a path. No runbook with 17 manual steps. No praying to the deploy gods on a Friday afternoon. This is GitHub Actions. And in this chapter, we are going to build your very first workflow from scratch in under 5 minutes. By the end, you'll have real automation running in a real GitHub repository, and you'll understand every single line of code that makes it happen. The era of manual deployments is over. Let's write your first pipeline. Before we write a single line of YAML, let's be crystal clear about what we're building and why it matters. By the end of this chapter, you will have a file at .github/workflows/hello.yml that automatically runs on every single push to your main branch. When it runs, it will spin up a fresh Ubuntu Linux virtual machine on GitHub's infrastructure, check out your code, and print the words "Hello, GitHub Actions" to the logs. That's it. Simple by design. Now you might be thinking, that's a toy example. But here's what you're actually learning. The exact same structure this tiny workflow uses is identical to the workflows that deploy Netflix, run Microsoft's CI pipelines, and test every single pull request at Airbnb. The skeleton is universal. Only the commands change. We're going to create the file, commit it, push it to GitHub, and then watch the pipeline turn green in real time in the Actions tab. 3 steps. 5 minutes. Let's go. Here's the first thing that surprises most people about GitHub Actions: there is zero configuration in the GitHub UI. No dashboard to set up. No project to create. No webhook to register. You simply create a file in the right place, and GitHub does the rest. That place is .github/workflows/ a directory at the root of your repository. GitHub watches this directory constantly. The moment you push a .yml file into it, GitHub reads it, understands it, and registers it as a workflow. It's that automatic. Notice the dot at the start of .github. On Mac and Linux, this makes the directory hidden by default, so if you're browsing your files in Finder or a file manager and wondering where it went, use lsla in your terminal. It's there. One critical gotcha: the directory must be at the absolute root of your repository. Not inside src. Not inside packages. The root. And your file extension must be .yml or .yaml, anything else and GitHub silently ignores it. Get this right and everything else falls into place. Every GitHub Actions workflow file, no matter how complex, is built on 4 top-level keys. Think of them as the 4 questions your workflow must answer to make sense. The first is name. This is purely cosmetic, it's the label that appears in the GitHub Actions tab in the UI. Make it human-readable. CI pipeline or deploy to production, something a teammate can scan and understand instantly. The second is on. This is arguably the most important key. It answers the question, what event should wake this workflow up? A push? A pull request? A scheduled cron job? A manual button click? We'll dig into this on the next slide. The third is jobs. This is where the actual work lives, the virtual machines, the steps, the shell commands. Everything your pipeline does happens inside jobs. The fourth is env. This is optional, but powerful. It lets you define environment variables that are available to every job and step in the workflow. Things like node_env or API-based URLs that shouldn't be hard-coded in individual steps. Only on and jobs are strictly required. But knowing all 4 means you understand the full skeleton of any workflow you'll ever encounter. The on key is the event listener of your entire workflow. It's the contract you're making with GitHub: run this pipeline when X happens. And X can be almost anything. For our Hello World workflow, we're using push with a branch filter of main. This means the workflow fires exactly once per push to the main branch. Push a commit to a feature branch? Nothing happens. Merge a pull request into main? Fires immediately. GitHub supports over 35 distinct event types. Push and pull_request are the workhorses, you'll use them constantly. Schedule lets you run a workflow on a cron expression, like every day at midnight. Workflow_dispatch adds a manual trigger button directly in the GitHub UI, which is incredibly useful for deployment workflows where a human needs to approve before running. You can also specify multiple triggers at once by listing them under on. It's common to run your test suite on both push and pull underscore request so you catch problems whether someone pushes directly or opens a PR. We'll explore all of this in depth in Module 3. For now, push to main is all we need. Under the jobs, key is where GitHub Actions really comes alive. A job is a named unit of work that runs on its own dedicated virtual machine, called a runner. Each job starts with a clean environment, no files from your previous run, no cached state, nothing. A fresh machine every time. You give your job any name you want. We're calling ours say hello. Then you specify runs on, which tells GitHub which operating system to provision. Ubuntu latest is by far the most popular choice. It's fast, it's cheap on Actions minutes, and the overwhelming majority of open source tooling assumes Linux. But GitHub also offers Windows latest and macOS latest. Windows is useful if you're building a .NET application or testing Windows-specific behavior. macOS is essentially required if you're building iOS or macOS apps, because Apple's signing tools only run on Apple hardware. Here's a key insight that trips people up: every job is completely isolated. If you have two jobs in the same workflow, they cannot see each other's files. If job A produces a binary and job B needs to deploy it, you have to explicitly pass it as an artifact. Isolation is a feature, it makes your pipeline reproducible, but you need to design around it. Inside every job is a list of steps, and this is where the actual work gets done. Every step is one of two things: a run step or a uses step. Understanding the difference is fundamental to everything you'll build with GitHub Actions. A run step is just a shell command. Whatever you would type into a terminal on an Ubuntu machine, you can put here. Echo a message. Run your test suite with npm test. Build a Docker image. Compile a binary. It's pure bash, which means you can do anything. Multiline scripts use the pipe character followed by indented lines, just like writing a shell script inline. A uses step is different. It invokes a pre-built action, a reusable piece of automation that someone has already written, packaged, and published. The format is owner/repo at version. The most important action you'll ever use is action/checkout at v4. This is GitHub's official action that downloads your repository code onto the runner. Without it, your runner VM has no idea your code even exists. Think of uses as importing a library, and run as writing the code yourself. In practice, you'll use both constantly: actions for common tasks like checkout, setup node, or Docker build, run for your project-specific commands. Here it is, the complete workflow file. Read it from top to bottom and notice how it flows exactly like a story. Name tells you what it's called. On tells you when it runs. Jobs tells you what machine to use. Steps tell you what to do on that machine. Each section answers exactly one question. The first step uses action/checkout at v4. This is the action that clones your repository onto the runner. GitHub provisions a fresh virtual machine. It has no idea your code exists until checkout runs. Without this step, your subsequent run commands would have nothing to work with. The second step runs a simple echo command. This is your hello GitHub Actions. The proof of life. When you see this line in the live logs, you'll know your pipeline is working end to end. The third step runs date, which prints the current timestamp. It's not glamorous, but it confirms your runner is alive, connected, and responding. Pay close attention to the indentation. YAML is whitespace sensitive, 2 spaces here, 4 spaces there, and the structure is completely defined by indentation levels. If something breaks, a wrong indentation is the first thing to check. Copy this file exactly, and you'll be green on the first try. The file is written. Now it's time to make it real. 3 git commands are all that stand between you and your first green pipeline. First, git add.github/workflows/hello.yml stages your new file. Be specific with the path, you don't want to accidentally commit anything else that's sitting in your working directory. Second, git commit with a clear message. Add hello workflow is perfect, it's descriptive, it's present tense, and a teammate reading the git log 6 months from now will immediately understand what this commit does. Good commit hygiene matters even for automation code. Third, git push. The moment this command completes and GitHub receives your commit, the gears start turning on the other side. GitHub detects a push event on main, scans.github/workflows/, finds hello.yml, matches the on push trigger, and begins provisioning a runner. Here's what happens in those next 2 minutes. GitHub queues your job, assigns it to an available Ubuntu latest runner, clones your repository, and begins executing each step in sequence. You'll be able to watch all of this happen in real time, which brings us to the Actions tab. Open your repository on GitHub and look at the top navigation bar. You'll see tabs, code, issues, pull requests, actions. Click Actions. This is your mission control, the central hub for every workflow run in your repository. On the left sidebar, you'll see your workflows listed by name. Click Hello GitHub Actions and you'll see a list of runs. The most recent one should be at the top, showing the commit message add hello workflow. Look at the icon to the left of the run title. A green checkmark circle means every job in that run passed. Every step exited with code 0. Your pipeline is healthy. A red X circle means at least one job failed. A yellow spinning circle means the run is still in progress, the runner is actively executing your steps right now, in real time. Click the run title to drill down. You'll see the job graph, in our case, a single job called Say Hello. The green checkmark next to it confirms it passed. Click the job name to open the log viewer, which is where the real magic happens. Everything your steps printed to stout is right there, timestamped, waiting for you. The log viewer is one of the most powerful features of GitHub Actions, and most beginners scroll past it too quickly. Let's slow down and understand what you're seeing. Each step in your job appears as a collapsible row. Click the arrow next to a step name to expand its logs. For the Say Hello step, you'll see exactly 2 lines, the command that ran run echo hello GitHub Actions. And then the output below it, hello GitHub Actions. That's your pipeline talking back to you. Every log line has a timestamp on the left wall clock UTC time. This is incredibly useful for performance tuning. If your pipeline takes 8 minutes and you need to cut it in half, you expand each step and look at the timestamps to find where the time is actually going. Often it's a single slow step, a package install, a test suite, that accounts for 80% of the runtime. At the top right of the log viewer, there's a View Raw Logs button that downloads the entire log as a plain text file. This is invaluable when you need to search for a specific error message that's buried in thousands of lines of output. And if you click any line number in the logs, GitHub generates a direct URL to that exact line, perfect for pasting into a Slack message when asking a teammate for help. Let's talk about failure, because it's going to happen, and you need to know exactly what to expect. When any step in your workflow exits with a non-zero exit code, GitHub Actions considers that step a failure. Exit code 1 means general error. Exit code 127 means command not found. Anything other than 0 is a failure. The moment a step fails, GitHub stops executing the remaining steps in that job. They get skipped entirely, marked in the UI with a gray dash. The job is marked as failed, and the overall workflow run shows a red X. GitHub also sends you an email notification, which you can configure in your notification settings. In the logs, you'll see the exact command that failed, the error output it produced, and the exit code. This is your debugging starting point. 9 times out of 10, the error message tells you exactly what went wrong: a missing file, a syntax error, a failed test assertion. There's a powerful escape hatch called continue on error, true. Add this to any step and GitHub will let the step fail but continue running the remaining steps anyway. This is useful for things like code coverage reports that are informational but shouldn't block your build. Use it sparingly. You generally want failures to stop the pipeline so broken code doesn't propagate further. Here's a scenario you'll encounter regularly: your workflow fails, but not because of anything wrong with your code. Maybe a third-party API was rate limiting. Maybe the package registry had a momentary hiccup. Maybe GitHub's own infrastructure had a blip. These are called flaky failures, and they're a fact of life in distributed CI systems. The good news: you don't need to push a new commit to re-trigger your workflow. Open the failed workflow run in the Actions tab and look for the Rerun Jobs button in the top right corner. Click it and you get 2 options. Rerun all jobs restarts the entire workflow from scratch on the same commit. Every job, every step, back to the beginning. This is what you want when you're not sure what caused the failure. Rerun failed jobs is smarter. If your workflow has 5 jobs and only 1 failed, this option reruns only the failed job, skipping the 4 that already passed. On a large pipeline that takes 20 minutes, this can save you a lot of time. There's also a checkbox to enable debug logging. Check this on rerun to get verbose diagnostic output from the runner itself, things like environment variable values, network calls, and action internals. It's noisy, but invaluable when you're debugging something subtle. You've done it. You've written your first workflow, pushed it to GitHub, and watched it run live in the Actions tab. Before we move on to Module 3, where we explore all the trigger types in depth, let's lock in the most important structural concept from this chapter. There are 4 top-level keys in a workflow file: name, on, jobs, and env. Each one answers a different question. Name labels the workflow. Jobs defines the work. Env sets global variables. But only one key tells GitHub when to run the workflow. Only one key is the event listener, the trigger, the wake-up signal. Look at the 4 options on the right and pick the key whose sole job is to say run this when X happens. Think about the YAML you just wrote. Which key did you put push under? Which key had the branch filter? Take a moment. Trust your instincts. You read the file. You committed it. You watched it fire. The answer is already in your memory, you just need to surface it.